With this video, you can always pause, do some work, and come back to check your work. So let's start with do first. We have a system of linear equations right here. We don't care to solve. We already solved last week. Let's just make a matrix to practice. We have 3 equations. That means we'll have 3 rows. We have 3 variables in the constant. So we're going to have 4 columns, X, Y, Z, and the C column. Now let's just write the coefficients in the matrix. For the first row, we have an invisible 1 next to the X, 3, 2, and 7. Second row, we have a 2, an invisible -1, an invisible +1, and a 9. And for the last one, invisible -1, 4, 5, and 14. And that's the matrix for this problem. Now if we go to explore, there are 3 possibilities for solutions, and they are 1 solution, no solution, or infinite solutions. So for the first one, if we interpret, we see that we have 1x plus 0y plus 0z equals a. So we only write 1x equals a, or x equals a. For the second row, we have y equals b, and for the last row, we have z equals c. So then we have 1 solution, and the solution is ABC. Remember that ABC in this instance stands for numbers. They could be 1, 2, 3, 4, 5, 6. Now for the second one, we have x equals a, y equals b, right? Just some number. And then in the last one, do we have a z? We don't have a z, we just have zeros. So that means that we have 0 equals 0. And that's when we ask, is this true? It is true. So that means that we have infinite solutions. Same goes for the last one. Although we have x equals a and y equals b, that doesn't matter because once we go to the third row, we see that we don't have a variable. We just have a 0 equals 1. And when we ask if this is true, it is not true, it's false. So that means that the answer is no solutions. So just to do a recap, you're either going to get all variables on the left and numbers on the right, giving you 1 solution. You'll get the last row that has all zeros, meaning infinite solutions, or the last row giving you 0 equals 1, which is false and is no solution. So let's do an example and see where we are going to get these matrices from. These matrices are a special format called reduced row echelon form, and you get them from the calculator. So for example, we have a system right here of 3 equations. We're going to write a matrix so that we can put it in the calculator, and that calculator will give us an answer. So take a couple of seconds to make your matrix. Okay, now that you have the matrix, we're going to put it in the calculator, and I'll show you in a little bit how to do that. But let me just give you the answer for now. The calculator is going to put out an answer like it's showing right here under reduced row echelon form. The good thing about that is that you already know how to read a matrix, right? So if the calculator gives you this, you can already make equations from it. We see that x equals 2, y equals 1, and z equals -2. And so your solution is going to be exactly that, 2, 1, -2. So let's see how we can get the reduced row echelon form from the calculator. So we have the same example here, and you can follow the instructions on the worksheet, or you can follow this video I'm about to show you in the calculator how to do it. So first you write your matrix. We already did that. So I'm going to copy and paste my answer here. Now let's put this matrix in the calculator so that we can get our answer. So you're going to open the calculator, then you're going to click menu, number 7 matrix, and then number 5 reduce row echelon form, or ref for short. You can also get there by just typing the word RREF, ref, and then putting parentheses. After that, you're going to click on the button right underneath delete, the one where you click to put fractions, and you're going to click on the biggest matrix. But it doesn't matter though, because it's gonna ask you how many rows and columns you want. We want 3 rows and 4 columns, and then we click enter. And now we can put in the matrix that we made from the 3 equations. We click enter, and it gives out the ref matrix, which you already know how to read. I wrote the answer here again, and so we get the solution of x equals 2, y 1, and z negative 2. For elaborate one, you can pause the video, complete it, and then come back to check your work. I'm not gonna do all of them, but I will do some of them if you want to follow along, or if you want to open the exemplar in Schoology. It also has the answers so that you can check your work and follow along with it. For number 2, I'm rewriting the equations so that we get the variables on one side and the constant on the other side. So for the first one, I'm moving my y to the left by doing the opposite, so which is adding. So I'm rewriting, putting it in order x, y, z, and then the constant. I'm moving my equation right next to my old equation and just scratching it off so that I don't accidentally use the old one. For the second equation, there are different things that you can do. I want to leave my 4 on this side, so I'm going to move my z and my x to the left by doing the opposite. So I'm adding the z and I'm subtracting the x, and then I'm canceling on the right. On the left, I'm rewriting in order of x, y, z, and then we only have 4 on the right side. You could have also moved the y to the right and the 4 to the left, ending up with a negative y and a negative 4. So either or is correct. And then for the last equation, I'm just moving my x to the left by doing the opposite. It's negative, so now we're going to add. And I'm putting it in order from x, y, z. And we have a 1 left on the right side. For the rest of the problems, you can pause the video, complete, continue on your own, and then check your work. Again, the exemplar is in Schoology, and then you can come back here to continue with the worksheet. So now for a recap, let's write like a boss. So how can you tell if a system has no solution? And then how can you tell if a system has infinite solutions from a ref matrix? Okay, so another way that you can use your TI calculator is if they give you the equations, you can use linear solve in your TI so that it could solve the equations for you. Now, this is a better option. I prefer to use linear solve. If you have a TI and they give you equations, always go for linear solve. Why? The reason is you don't need to have your equations in standard form, and you're gonna see in a little bit when you do different problems. And also, you do not need to have your equations in terms of x, y, and z as well. And you're gonna see that in a little bit again with the different problems. Now, the only downside is that you can only do this if you have a TI calculator. So if you don't have one, I'm also going to show you in a video how to graph the linear equations and get your solution from there. So if you do not have a calculator, go to the graphing example and practice doing all your problems via graphing. So the way that you do linear solve in the calculator is by going to menu, algebra, and then number 2, solve linear equations. And then you're going to choose 3 because we have 3 equations. And then for the x, y, don't worry, once you put enter, it's going to automatically also put a z, but you can put the z if you want to yourself. Now it gives you the 3 spots where you can put your equations. Again, they don't need to be in order, but it just so happens that these are. So we put them in. We put enter, and it gives you the solution right away, which is -1, 1, and 2. Now I do want to go over a little bit of over the special solutions. So you know when you get infinite solutions from a ref matrix, right? You get 0 equals 0 on the last row. But from a TI calculator, if you get crazy stuff like this, then that means infinite solutions. And if you want an explanation, I wrote a short one here. You can also get no solution. Again, from the matrix, you're going to get the last row saying 0 equals 1. But from the TI, you're literally going to get a message that says no solution. So you have reached elaborate 2. I did not print out this part. You can go to Schoology for the complete worksheet, and you can work the problems out in a separate piece of paper or in your notebook. Follow the worksheet and then check your answers with the exemplar that is also in Schoology. Reminder that if they give you linear equations, then use linear solve in your calculator. But if they give you a matrix, then you can use the matrix calculator. Also, be careful and read the problems. Some questions are not asking for a solution, but they're asking for a specific value. So for example, number 2 is asking for value of r, and number 4 is asking for for the y value. I'm about to do problem number 3, so you can pause the video, complete 1 and 2, try to complete 3, and then you can come back. I wanted to do number 3 because I wanted to point out how you don't have to have the equations in standard form, and you don't have to also use XYZ. So I'm writing out the problems with JKM. The thing is, if you don't tell the calculator that you're using JKM, it's going to give you an error. So either whenever you put 3 equations, you can declare that you're using JKM, or whenever you put the equations, you can declare right then and there that you're using JKM, and then click enter. And for this problem, we have no solution because there is no solution for this system. So I'm doing number 7 to show you how to do a system of linear equations via graphing. I already put in my first equation. At first, it's going to give you like a warning. It's going to ask you if you want to add a z slider, put yes. And then you can put in the other 2 equations before the slider. When you graph, a solution is where the 3 lines cross, right, where they touch. And if you notice right now, when I move the slider to the right, to the positive 1, 2, we notice that the line is getting farther from touching. So then that means that we have to move the slider to the left. As I move the slider to the left, I see that it's getting closer to crossing. So I'm going to zoom in a little bit so that I'm able to tell better. And then I stop here. This is where they cross. I click on the dot where they cross, and it tells me that X is -2 and that the Y is 7. And then Z, we already know because that's what the slider tells us. Z is -5. So then when Z is -5, X is -2, and Y 7, the lines cross at this point. So that is our solution. When you take the test, you will have Desmos, and Desmos is able to do this. So this problem or this way of doing it, if you don't have a TI calculator, make sure that you're working the rest of the problems via graphing so that you get used to this method. Okay, we have reached elaborate 3. This first problem is on your worksheet. Complete it on your own. Check your work via the exemplar in Schoology. Finish the last 2 problems, problems 2 and 3. They're not on the worksheet, but they are in Schoology. And then finally, when you're done, work on your exit ticket. And you have homework that is due the next time I see you is 2 questions.